Hi everybody, Dr. Nigro here with another screencast, this time looking at vertical motion and focusing on constant acceleration. All right, so as we saw when we looked at velocity, when you change your direction or your speed, right, then you are changing your velocity. All right, the rate at which your velocity changes is called acceleration. All right, and similar to what we saw with speed and velocity, you can have a constant acceleration, instantaneous acceleration, or an average acceleration. In this course, we're going to focus on constant acceleration. So what does that really mean? All right, if you're moving at constant acceleration, that means that your velocity changes by the same amount every second. All right. So let's think about what that really means. So does an object moving with constant acceleration also have constant velocity? Why not? Well, here, if we have acceleration, we have to have changing velocity. We can't have constant velocity. So the answer here is no. All right. If an object's moving with constant acceleration, then your velocity must also be changing. All right, so it's really important to keep that in mind. If you're accelerating at all, then your velocity is also changing. All right, so let's see our second question. Does an object moving with constant velocity also have constant acceleration? Why or why not? All right, well, it's the same idea here. All right, the answer is no, because if you're moving at constant velocity, then you cannot be accelerating. All right, so if your velocity is constant, then no acceleration. All right, so let's talk a little bit more about what this looks like. All right, so if an object moves at constant acceleration, this means that the velocity is changing in a regular way. So every second it changes by the same amount. So that means that we can calculate an average velocity in a new way. All right, so before we talked about how average speed and average velocity were total distance divided by total time. All right, but in this case, we know that if that velocity value is changing in a way that is constant, all right, that we can calculate the average velocity by looking at our initial position and our final velocity values and just dividing by 2. All right, so in other words, that constant acceleration means, sorry about my spelling, means the change in velocity is regular or predictable. All right. All right. Now, one thing we haven't talked about all that much so far is distance. All right. So distance. All right. We really need a formula that lets us calculate distance when we have changing velocity. We know that if we know average velocity, we can get to distance. But what about if we don't have the average velocity? All right. So if we want to calculate that distance, it's a combination of 3 formulas we already know. All right. So we know that the average velocity is the total distance divided by time. We also know that it's equal to, the final velocity plus the initial velocity divided by 2. All right. And then finally, we learned in the last unit that that final velocity is equal to the initial plus acceleration times time. So if we combine these, rearrange and solve for distance, we get a new formula, v initial times time plus 1/2 at squared. All right. All right. So in working problems, we got to organize our information like we did before, and we got to watch our units. Remember, those units must match. All right. And we got to make sure we're paying attention to what the problem asks for. All right. And as with before, watch out for words from rest, to rest, stopped, and constant. They are important. All right. So instead of just using v final, v initial, acceleration, and time, now we're going to include distance. Okay. All right. So let's look at a couple practice problems so we can try to use our new formula. All right. So for our first problem, it says, imagine you're a drag racer. Your acceleration is 26.6 meters per second, and your final velocity is 146.3 meters per second. What was your total distance traveled? All right, so V final, V initial, acceleration, distance, and time. So let's see what we know. We have an acceleration of 26.6 meters per second squared, and we have a final velocity of 146.3 meters per second. All right, so since we're a drag racer, we started from rest, so that initial velocity is 0. All right, so the question's asking about distance. As you're going to find with most of these problems, you usually have to find time first. All right, so the first thing we're going to do is find time. All right, so I'm going to use my acceleration formula. So acceleration equals v final minus v initial over t, because I know acceleration, I know v initial and v final. All right, so that means that time is going to be equal to v final, which is 146.3, minus v initial, which is 0, divided by my acceleration of 26.6 per second squared. All right, that's going to equal 5.5 seconds. So there's time. And now that we know time, I can use my new distance formula, v initial times time plus 1/2 at squared. All right, in this case, v initial 0, so this piece goes away, and it's just 1/2 times our acceleration, 26.6 meters per second squared, times 5.5 seconds squared. All right, so we plug that all into our calculator, and we find that our object, our drag racer in this case, has moved 402.3 meters during that 5.5 seconds if they're accelerating at that rate. All right. All right, so let's try another one. All right, so in this one, we have a jetliner traveling north that lands at a speed of 69 meters per second. Once it touches down, it has 750 meters of runway to reduce its speed to 6.1 meters per second. What was the acceleration? All right, so V initial, V final, acceleration, distance, and time. All right, so we look, this time V initial is 69 meters per second. That's what we landed. All right, and we taxi to a speed of 6.1 meters per second. And we do that over a distance of 750 meters. All right, so to find acceleration, if I look at my formulas, again, I'm going to need to find time first. All right, so with the information that I have the easiest way to find time without having to use acceleration is to use my V average formula. So V average is V final plus V initial divided by 2. So in this case, 69 meters per second plus 6.1 meters per second divided by 2. So my average velocity of the plane is 37.55 meters per second. But we're not quite done. This doesn't get us the time. All right, now we're going to use the other formula for V average, which tells us that is distance divided by time. So that means time is equal to distance divided by V average. All right, so we plug in our 750 meters, our average velocity of 37.55 meters per second. We're going to find it's going to take us 20 seconds to taxi down the runway and reach our final speed. All right, so with that information, now I can use my acceleration formula, which is V final minus V initial over t, plug in my 6.1 meters per second minus my 69 meters per second, and divide that by 20 seconds. All right, so if I plug that all into my calculator, I'm going to find a negative 3.15 meters per second. All right, now the negative sign here is good because we are slowing down. Our velocity is all positive, which means to slow down, we need the sign of our acceleration to be negative. All right. All right, so I'm going to let you try the other two. I will post them on the key for you so you can see your answers. And if you have any questions, please let me know.